हेलो गाइस, आज की इस वीडियो लेक्चर में हम टाइप्स ऑफ मल्टीमीडिया नेटवर्क एप्लीकेशंस के बारे में जानेंगे और स्ट्रीमिंग स्टोर्ड ऑडियो एंड वीडियो मल्टीमीडिया नेटवर्क एप्लीकेशन की टाइप के बारे में पढ़ेंगे। तो हम स्टार्ट करते हैं। टाइप ऑफ मल्टीमीडिया नेटवर्क एप्लीकेशन। द इंटरनेट सपोर्ट अ लार्ज वैरायटी ऑफ यूजफुल एंड entertaining multimedia applications. In this subsection, we clarify multimedia application into three broad categories: streaming stored audio and video, conversational voice video over IP, and streaming live audio video. As we will soon see, each of these application categories has its own set of services requirements and design issues. Streaming stored audio and video. To keep the discussion concentrate, we focus here on streaming stored video, which typically combine video and audio components. Streaming stored audio is very similar to streaming stored video, although the bit rates are typically much lower. In this class of application, the underlying medium is pre-recorded video such as movies, a television show, and pre-recorded supporting events or pre-recorded user-generated application. These pre-recorded videos are placed on the server and the user sends requests to the server to view the videos on demand. Many internet companies today provide streaming video including YouTube, Netflix and Hulu. By some estimate, streaming stored video make up over 50% of the downstream traffic in the Internet Access Network today. Streaming stored video has three key distinct features: streaming, interconnectivity, continuous playout. Streaming. In streaming stored video application, the client typically begin video playout within a few seconds after it began receiving the video from the server. This means that the client will be playing out from one location in the video while at same time receiving later part of the video from the server. These techniques are known as streaming. Avoid having to download the entire video file before playout begins. Interactivity. Because of media because the media is pre-recorded, the user may pause, reposition forward back, fast forward and so on through the video content. The time from when the user makes such a request until the action manifests itself at the client should be less than few seconds for acceptable responsiveness. Continuous playout. Once playout of the video begins, it should proceed according to the original timing of the recording. Therefore, data must be received from the server in time for its playout at client. Otherwise, the user experiences video frame freezing when the client waits for the delayed frame, or frame keeping when the client keeps skip over delay time. By far the most important performance measure for streaming video is average throughput. In order to provide continuous playout, the network must provide an average output to streaming application that is at least a large the bit rate of video itself. By using buffering and prefetching, it is possible to provide continuous playout even when the throughput fluctuates as long as average over 5 to 10 seconds remain above the video rate. For many streaming video applications, pre-recorded video is stored on and streamed from a CDN rather than from single data center. There are also many P2P video streaming applications for which the video is stored on users' host pair with different chunks of videos arriving from different peers that may spread around the global. Given the prominence of internet video streaming, we will explore video streaming in some depth in section 2.2, paying particular attention to client buffering, pre-patching, adapting quantity to bandwidth, availability and CDN distribution. Thank you for watching and listening this